Welcome to the deep dive. Get ready to explore something really quite fascinating today. Cyclodextrins, or CDs.
Yeah, we've got a lot of material here. They pop up everywhere.
They really do. From health and wellness uses to, well, some surprisingly innovative applications in everyday life, and even beyond that, actually.
What's really captivating, right off the bat, is how elegant these molecules are. Simple almost.
Oh, okay.
Imagine a tiny, tiny donut, a ring made of sugars. But there's a twist.
A twist.
This ring, it has a sort of dual personality. The outside loves water, but the inside, it repels water. Hydrophobic inside, hydrophilic outside.
Right. Okay, so that's structure. That's the key.
That's the key. Lets them grab onto molecules that don't mix well with water, sort of tucking them away inside that water-repelling center.
Ah, like a little molecular hideout, giving those water-hating molecules a safe space.
Precisely. And this seemingly simple function opens up a remarkable range of possibilities.
Yeah, our sources mention everything from cosmetics and household cleaners to medicine, food science, even agriculture.
Exactly. But today, we're really zeroing in on those aha moments, how CDs are used to boost the properties, the benefits of different compounds, especially in, nutraceuticals and food.
Okay, let's dive into nutraceuticals then. It sounds like these CDs are doing more than just carrying stuff around. They're actively making things better.
Oh, absolutely. It's all about how that encapsulation we mentioned translates into real-world advantages for these bioactive compounds.
How so?
Well, the sources highlight how CDs can seriously improve a compound's solubility, how well it dissolves. Also, its dissolution rate, how fast it gets to work.
Okay.
And its stability, how long it lasts. Even how well it mixes into liquids, the wetting.
Right.
And the big one, absorption or bioavailability, how much your body actually gets.
Right, so the CDs are basically acting like chaperones, helping these molecules get absorbed more effectively and maybe in larger amounts.
You got it. But the benefits don't stop there.
Oh.
By improving these basic things, CDs might actually lower the dose you need for something to work. Plus, they can mask unpleasant tastes and smells. Think about some supplements. It's a huge plus.
Definitely. Anything else?
Yeah, they can also reduce unwanted interactions between different ingredients in a mix and potentially even lower toxicity or side effects. It's quite a list.
It really is. Which makes you wonder, are they safe? I mean, we're talking about consuming these things.
Crucial question. And yes, our sources are clear on this.
Yeah.
Regulatory bodies in the U.S. and Europe have approved specific types alpha, beta, and gamma cyclodextrin for food and nutraceuticals.
Okay. Yeah.
It's based on their low toxicity, minimal risk.
Yeah.
In the U.S., they have GRAS status,
Yeah.
generally recognized as safe.
GRAS, right. Heard of that.
And the EU has its own classifications, even recommendations for daily intake levels. So, yeah, they're widely accepted as safe.
That's reassuring. Okay, let's talk specifics. Examples. Our sources are full of them. Coenzyme Q10.
CoQ10.
CoQ10, yeah, perfect example. It's vital stuff, energy production, antioxidant. But it's famously tricky for our bodies to absorb because it doesn't dissolve well in water.
Our info shows that when you encapsulate it with gamma cyclodextrin or GCD, the bioavailability shoots up by 18 times.
18 times. Wow.
Yeah, 18. That's a massive increase in how much your body can actually use. Plus, it helps solubility and stability, too. You see products like Kive Q10 using this.
That really drives home the impact, doesn't it? What about curcumin? The stuff in turmeric. Another one known for benefits but poor absorption.
Exactly the same issue. Potent anti-inflammatory, antioxidant, but tough to get into the system.
So CDs help there, too.
Big time. Complexing it with GCD, according to our sources, not only makes it a nice, easy-to-handle powder, but boosts absorption by about 40 times.
40 times.
Roughly 40 times, yeah.
Yeah.
There's an ingredient called cathicarmin based on this. It really shows how CDs can unlock the potential of these compounds.
Incredible delivery systems. Okay, what about CBD? Cannabidiol, that's huge right now.
Yeah, and like many cannabinoids, CBD isn't very water-soluble, so again, absorption issues.
CDs to the rescue.
Seems like it. They're proving really effective at boosting CBD's solubility and bioavailability. This opens the door for new product types, like water-soluble hemp powders you can put in capsules easily, make CBD more accessible.
And it's not just the big names, is it? Alpha-lipoic acid was mentioned too?
Correct. Another antioxidant. The claim is increased bioavailability and stability when complexed with GCD. Seems consistent with other findings.
Okay. Then there's resveratrol, always linked to that French paradox, right? Red wine, heart health.
That's the one. And there's a product, microactive resveratrol, that uses beta-cyclodextrin, BCD. the claim.
Mm.
2.5 times better bioavailability than standard resveratrol.
2.5 times. Still significant.
Absolutely. Could potentially amplify its benefits.
If even a Manuka honey is getting this treatment, seems pretty straightforward already.
Well, Manuka honey is valued for unique properties, antibacterial stuff.
Right.
So Manuka honey cyclopower uses alpha-cyclodextrin, ACD. The idea is to encapsulate the active bits, protect them, and maybe enhance how well they work or get absorbed.
It really feels like anything beneficial that struggles with absorption is a candidate for CDs. Essential oils. They're tricky too. Volatile, don't like water.
Precisely. Essential oils have benefits, but applying them can be limited by that volatility and poor solubility.
So CDs.
CDs offer a neat solution. They can basically turn these liquid oils into a stable powder. Much easier to work with in products like capsules or tablets. And again, improve stability and potential bioavailability.
And vitamins, of course. The basics.
Can't forget vitamins. The general advantages apply. Protection from degrading, better dissolving, enhanced bioavailability.
Any specific tech there?
The source mentions cyclosome technology. Sounds fancy, but it's basically using CD complexes inside liposomes, tiny fat bubbles, for potentially even better delivery, seen in things like CAVQ10 and some prenatal vitamins.
Wow. One molecule type, so many applications just based on that structure. But hang on, you mentioned empty CDs having benefits too, without anything inside.
Yeah, that's interesting, isn't it? Even on their own, they can do things, like masking tastes or odors. And some types act like dietary fiber, which can influence your gut bacteria positively. There's also some suggestion they might affect cholesterol levels and how we handle sugar, our glycemic response. So, potentially good for metabolic health, too.
So, not just delivery, guys. They have their own tricks. Okay, let's pivot to cholesterol. Sounds like CDs have a special relationship there.
They really do. Our sources emphasize how good CDs are at encapsulating cholesterol. That water-hating interior cavity is perfect for trapping cholesterol molecules.
Forming inclusion complexes, right?
Exactly. Traps the cholesterol, makes the whole complex more water-soluble. You can even buy water-soluble cholesterol CD complexes commercially.
Okay, so if they grab cholesterol and make it dissolve in water, what does that mean practically?
Well, it could make it easier to remove cholesterol from the body, maybe from cell membranes, even from food products. It can also change how cell membranes behave if their cholesterol content is altered.
Which leads to potential medical uses.
Yes, that's driving a lot of research. Using CDs themselves, or derivatives, as potential drugs for diseases where cholesterol builds up.
Like what?
Niemann-Pick disease type C is a big one, a rare genetic condition. An IV cyclodextrin derivative is being studied there. But also Alzheimer's, Parkinson's, familial hypercholesterolemia that's inherited high cholesterol, a kidney disease called FSGS, and even maybe as antidotes for some poisons or venoms.
That's a really diverse range of potential therapies. But the cholesterol link isn't just diseases, right? Something about sperm quality.
Yeah, that was an unexpected one. Cholesterol in sperm membranes is important, especially for freezing sperm cryopreservation.
Okay.
Studies suggest adding cholesterol loaded onto a specific CD, methylated beta CD, before freezing improves sperm quality after thawing. And using it after thawing seems to boost fertility rates by enhancing capacitation, their ability to fertilize an egg.
Huh. From rare diseases to fertility. And then there's something about imaging, biotechnology.
Oh, right. This is really cool. A specific CD, 2-6-dimethyl-BCD, allows researchers to stain whole organisms, like mice, uniformly with standard antibodies.
How does that help?
It reveals detailed cellular and structural maps across the entire body. You can see proteins in their natural context much more easily. It's a powerful tool because it works with lots of existing antibodies.
Amazing adaptability. Okay, let's bring it back to food. You mentioned cholesterol removal there, too.
Yes, definite industry applications. A key example is the Blotti brand butter and cream from Cormico. They use CDs
To do what exactly?
to selectively pull out up to 98% of the cholesterol. And the key is it doesn't significantly mess with the other nutrients or, importantly, the flavor.
So lower cholesterol butter that still tastes like butter, how's it work?
Basically, they add beta-CD to the milk or cream. It binds the cholesterol, forms an insoluble complex.
Which they can then remove.
Exactly. Spin it out, separate it, leaving the good stuff behind.
And eggs, those cholesterol-free eggs you see.
Yeah.
Similar idea.
Pretty much. Separate yolks and whites. Mix beta-CD with the yolks. It grabs the cholesterol, forms that insoluble complex again.
Spin it out.
Spin it out via centrifugation. Then recombine the treated yolk with the white, pasteurize it, and you've got significantly less cholesterol.
Okay, so clearly useful for making existing foods healthier, But the sources also mentioned broader uses in food, like as general additive.
Oh, absolutely. Beyond cholesterol, think stabilization.
Mm.
Flavors, colors, preventing things from settling out in drinks like hesperidin and citrus juice.
Right, stopping that cloudiness or sediment.
Yeah. And controlled release of ingredients, also improving texture, making powders flow better, preventing clumping.
And even in the packaging itself, that sounds wild.
It is pretty innovative. CD-based packaging, it can be designed to absorb unwanted things like odors.
Or release good things.
Exactly. Release antimicrobials, maybe insect repellents, often triggered by moisture. Or contain empty CDs to just soak up bad smells or keep good aromas in.
Like tiny smart sponges and emitters in the package. Okay, what about starchy foods? How do CDs help there?
Several ways, actually. They can act as dietary fiber, they can improve taste, texture, and they can slow down starch retrogradation.
What?
Retrogradation. It's basically what makes bread go stale. So potentially longer shelf life.
Ah, okay.
And importantly, they can lessen the blood sugar spike after eating starchy foods. EFSA, the European Food Safety Authority, even noted that alpha CD with starch can reduce that post-meal glucose response.
That's a big deal for managing blood sugar. And egg-free baking. CDs involved there too.
Yep. Alpha CD can create stable oil in water emulsions, even at high temperatures, meaning you can potentially replace eggs completely in baking mixes. Offers a vegan, kosher, halal, allergen-free option.
Ah, a game changer for many people. And there was that new seasoning concept, Dawn Main.
Right, Dawn Main. It's clever. It's a seasoning, salt, pepper, chili, but it also has cyclodextrin mixed in.
Why?
The idea is the CD binds to excess fats in the meal while you're eating, theoretically reducing how much fat your body absorbs, flavor without all the fat impact, potentially.
That is inventive. Seems the food applications just keep coming.
They really do. The list goes on. Cholesterol-reduced milk, longer-lasting foams, maybe reducing caffeine in coffee, masking bitterness, encapsulating acids, used in soft drinks, bakeries, dairy, gum, sports drinks. It's vast.
Okay, so food and nutraceuticals are huge areas, but that YouTube source really opened my eyes to just how far-reaching CDs are.
It really did, didn't it?
Yeah.
Those are major, sure, but the breadth of applications is staggering, goes way beyond food. Remember the packaging example, absorption, release. That principle applies elsewhere.
Like cosmetics, that was mentioned prominently.
Definitely a big one. Stabilizers, emulsifiers, solubilizers, helping active ingredients get into the skin bioavailability and permeation enhancement. Hydroxypropyl beta-cyclodextrin is super common there.
And fragrances.
Oh, yeah. Encapsulating fragrances for slow, controlled release.
And
odor masking. The classic example everyone knows is Febreze technology. That's CD-based.
Huh. So these sugar rings are managing how my living room smells. What about paintings? That seemed random.
Right. But you can incorporate CDs into paint, release fragrances slowly, or insect repellents, even anti-mold compounds for damp areas.
Okay, that's clever. And helping bees. Agriculture uses.
Yeah, exploring CDs for better pesticide delivery, improving bee nutrition by putting nutrients in their feed, even influencing the color of animal meat by adding encapsulated pigments to their diet.
Wild. From air fresheners to meat color. And trash bags.
Seriously.
Get this. Trash bags with mitt-loaded CDs. Masks the garbage smell, apparently, but also deters raccoons.
That's actually brilliant. And textiles.
Embedding fragrances that release as you wear the clothes. And during the pandemic, there was interest in antiviral masks using CDs for potential extra protection.
Even energy. Batteries.
Yeah, research looking into using them in lithium batteries.
Yeah.
Trying to improve performance, lifespan maybe? Still early days, sounds like.
And our teeth, oral hygiene.
Yep, found in toothpaste, mouthwash. Likely trapping odor molecules for fresher breath, maybe delivering other ingredients effectively.
Okay, the one that really got me. Space exploration. Huh? Yeah, that highlights a very specific CD property.
Chirality.
Chirality, like mirror images, left and right hands.
Exactly. CDs are chiral, so they can distinguish between other chiral molecules, like amino acids. That makes them super useful for analysis. On Mars missions, they're used in instruments to help detect amino acids' key signs in the search for life.
Wow. Humble sugar rings helping search for aliens. Okay, back on Earth, environmental uses.
Well, there's experimental work on using CDs to capture CO2 from the air. Climate change mitigation.
Ambitious. Anything more? Current.
Yes. Water purification. Using CD-based polymers to remove PFAS, those nasty forever chemicals. Commercial filters using this tech are actually available now.
That's hugely important. And lastly, advanced materials.
Right. CDs as building blocks in special coatings, car paints, even 3D printed medical devices. They can form these things called polyrotaxines, CDs threaded onto polymer chains, making materials that are both flexible and strong.
It's honestly mind-boggling. From inside our bodies to paints, space, the environment. These cyclodextrins are way more than just simple sugar rings. So yeah, wrapping it all up, the big takeaway from this deep dive has to be the sheer, incredible versatility of cyclodextrins.
These molecular containers.
Exactly. They have this massive range of applications. We focus a lot on boosting bioavailability and stability in nutraceuticals and food, which is huge.
But clearly it doesn't stop there. Cosmetics, environment, materials, science, space. It's amazing.
And it all comes back to that core ability, doesn't it?
Yeah.
That unique structure, the donut shape with the hydrophobic inside, letting them encapsulate molecules and change their properties in so many useful ways.
Which leaves us with a thought for you, our listener. We've seen so many applications, but what's next? Considering this incredible potential, what future innovations could leverage cyclodextrins?
Yeah, what new problems, big or small, could these simple sugar rings help solve? In our daily lives or in, bigger scientific challenges, the possibilities seem pretty endless.
Definitely food for thought. And if you do have more questions, or maybe even your own ideas about using cyclodextrins, you can actually reach out to CarboHyde. Their email is formulation@carbohyde.com.
Or check out their website, http://www.carbohyde.com. That's CARBOHYDE.com.
It's been a really fascinating deep dive today, truly illuminating. Until our next exploration.